Welcome back, guys. Today we're going to talk about, finish up on Chapter 5. And for the record, we will not have Chapter 6 on Test 2. That I'll load up Friday. So don't worry about Chapter 6. I'm going to put that on the next test when we talk about interviewing and interrogating. So today we're going to just spend a little time and focus on the last important part of evidence, which is ballistics. Clearly in the United States, this is a philosophical debate we can have forever and ever about guns in the United States. We're not going to have that debate. We clearly have a lot of guns in the United States. We clearly have a lot of crimes committed with guns. So being a forensic scientist, expert in ballistics is extremely important. As an investigator, as a police officer, you're going to need to know certain terms and have a basic understanding of ballistics, because when you testify in court, some of this stuff is pretty important, and you don't want to be using terminology that is not accurate. For those of you that have no experience with any type of firearms, it'll be easier for you because you're learning from scratch the terms that I'm going to be talking about today. For those of you that say shoot a lot, that you're sportsmen, that you hunt, you grew up hearing something and that's what you called it, and it's a little bit tougher for you. So when you get to court, you have to retrain your mind. There's certain terms we're going to go over. I'm not, obviously, you're not in a lab, so I'm not going to have you recreate how we do the types of things we're going to talk about today. I'm just going to be testing you on the definition, the vocabulary of certain terms when we start talking about ballistics. So let's start at the beginning and the chapter does an okay job talking about it, but not in depth to where I want you to have an understanding. So when we talk about ballistics and firearms, in the United States, well, worldwide, we basically put firearms in 3 categories. So know these categories. The first category is handguns. Clearly handguns are used in the United States in crimes probably more than any other firearm. So when we talk about handguns, there are specifically 2 types when we go to court that we deal with in handguns. The first are revolver. A revolver is a handgun that is the old Western style. That's got a cylinder that opens up. It's the round cylinder. When it opens up, you put the ammunition in. We'll get to what we call that. And then it closes back up. The second type is a semi-automatic, and this is what we see the most. A semi-automatic handgun basically has a slide, operates off of a magazine that comes in from the bottom, can shoot multiple rounds. So when we talk about handguns, we have semi-automatic and then we have revolvers. Both operate on the idea of a firing pin, and we'll discuss this when we get to some of the components. But basically with all guns, all firearms, there's a firing pin. It's a mechanism in this piece of machinery, nothing more than a pin, a metal pin. When you pull the trigger, this pin goes forward and it strikes that casing. We'll get to how it operates, but it's very, very simple, which is why handguns have been around for a long, long time. Right now, all I want you to understand is handguns is the first type of firearm. There are 2 types, semi-automatic and revolver. Clearly, when we go to a crime scene, there's going to be times we're not going to know what type of firearm was used because a lot of them interchange. It's a very, very complicated science. Right now, just know that handguns is the first type. The second type is shotguns. When we talk about a shotgun, this is generally a piece of machinery, has a firing pin just like the others, but shoots out a straight bore. We'll talk about that later. But it's a plastic casing that shoots out multiple fragments, bullets from that projectile. And it's a little bit more complicated when we're in a crime scene when a shotgun has been used, but it's pretty obvious in a crime scene to determine if it was a shotgun as opposed to a handgun. A lot of this, remember, you're going to be taking into account the forensic, the blood scene that you have based on what we talked about last time, blood spatter. So we've got handguns, we've got shotguns, and then we've got rifles. Rifles are what we consider long guns. They're generally the hunting rifles. They're the ones we see, the semi-automatic weapons that we see in a lot of the active shooters, the AR-15 type guns. We call them a rifle because the barrel on these long guns, almost all of them, inside of the barrel, we have what's called riflings. When the bullet, and we're going to talk about the bullets and the components, but when a bullet goes through a rifle, it's designed to spin that bullet. Think of a football, like a quarterback throwing a football. If they throw a spiral, that football is spinning. It spins because it can go further and straighter the more it spins. So in a rifle, we're making a bullet. Once that firing pin hits the bullet, inside of that steel barrel, there are grooves inside of there forcing that thing to turn. So as it goes out of the barrel, it's turning like a football. It's not that complicated, and there are many, many patents out there. Every patent from Glock to Smith & Wesson to Ruger to Remington, every gun has a specific way that that bullet comes out of the barrel. So when we look under a microscope at a bullet that we have taken from a body, we're going to know based on how that bullet was spinning, what type of gun it came out of, based on how fast did it spin, how slow did it spin. In fact, I'll give you an example. When we start talking about components, and it's really not complicated. For those of you that have never, ever been involved in any type of firearms, what happens generally is you have a casing. This is called a casing. A casing is nothing more than the brass or that type of cylinder that holds gunpowder. So a casing has gunpowder in it. On top of it sits a bullet. Do not call both of these together a bullet in court. This is ammunition. Casing, bullet. What happens is, and we're going to get to this, on the casing, and if you look at the back of it very carefully, you'll see that in the center of that is a primer. In the very center looks like a bullseye. Is nothing more than like a cap. When you were a kid, you had a cap with a hammer and it popped. It's like pop rocks. When that firing pin comes forward, it hits that primer. When it hits that primer, it causes an explosion. It sets the gunpowder on fire in the side of that casing, and the bullet comes out. When the bullet comes out, if it's in a rifle, and many handguns have rifling as well, as it's spinning, when we get the bullets out of the body or in a crime scene, you can see under a microscope, this is obviously blown up bullet, you're going to see these grooves inside of the lead bullet. These are just simply a fingerprint. When we look at this, we can look at the depth of that. We call these alleys and valleys, and mesas. They're lands and grooves. We can look at it and determine how deep they are, how wide between them, and we can pinpoint this had to be a Remington, it had to be a Ruger. Something else that's extremely important. When a quarterback throws a football, it's either going to spin to the right or it's going to spin to the left. If it's a Remington gun, it's going to spin right. Some guns will spin left. So we're going to know when we get on the stand, if we're trying to determine that the shooter, the suspect, shot a specific gun, we have to be very specific. When you look at this, you can see the way these are going, it's forcing this to spin to the left. When you're looking at it, these grooves are going out, making the bullet spin to the left. Sometimes it'll spin to the right. So the first thing that we're looking for on a bullet is which way did it spin based on the riflings. And remember, this whole lesson today, just like fingerprints, we're trying to get a match. We're trying to say the gun found at the scene, and now we know this person owns that gun. The bullet that was in the body had to be fired through that gun. First thing we're looking at is the bullet. On these bullets, under a microscope, we're going to be looking. Here's a real bullet. If you look at that closely, you'll see the lands and grooves. You can look at it and see that it has a left spin when it's coming out, or a left twist. So we're looking at this. Where else would we be looking for a fingerprint? Remember, on a casing, we talked about the firing pin coming forward and hitting that primer. So up here on the board, what I'm going to show you is this. The back of a casing, you're going to have the brass casing. You're going to have the primer. When that firing pin comes forward and hits, two things we look for. Number one, a firing pin is like a finger. When it strikes that soft brass, it's leaving behind a fingerprint that we can call a match between under a microscope, it had to come from that firing pin. We also know when we took the gun and took it to our lab, every time we fired it, when it came forward, it hit every time right here. Remember, a primer is pretty big under a microscope. When that firing pin comes out of that gun, every gun will hit in a specific spot. We could have the same gun off of an assembly line, factory line, that one gun hits right there, the next gun hits right here. Every time it shoots, it hits there. The next gun might hit here. So we're looking at the fingerprint identification. We're also looking at the location on the primer where it hit. We're going to get casings all over a crime scene. We can look at a casing and we can look at these specific things to determine it had to come from that person's gun. Another thing that we're looking at, if you come up here on this casing, every time this semi-automatic is fired, it throws out an empty casing. It's called an extractor. It's nothing more than a hook. So someone pulls the trigger, it shoots. It shoots out the empty casing. Empty casing goes flying out because a hook, think of it as a hook. There's an extractor in here. This hook grabs the side. If you look at that, there's a rim on that casing. If you look at that closely, that rim, a hook will come out, grab that rim, and pull it out, allowing for a new round to come in. Again, that's a fingerprint. Every time that hook comes out of that gun and grabs, under a microscope, we can determine that hook was a match to that gun. So I want you to know, bullet, casing, together they're ammunition or cartridges. Know the twist. Left twist, right twist. It's based on the lands and the grooves. Okay? Extremely important. The types of firearms. When we start talking about caliber, I don't want to confuse you. Upper division class will go into it. But look at this. We've got all kinds of different casings. Remember, casings. You're going to have to determine what type of gun did these casings come from. You know, you're not going to be guessing. Clearly, some of you might say, well, I know. Others, you're going to say, well, maybe I don't. How do we come up with caliber? Okay, first thing I want to tell you is, worldwide, we do not force any gun manufacturer, whether it's Smith & Wesson, Glock, Remington, there's nobody that says you have to do it exact. So if it just doesn't sound cool, they're not going to call it that. But the way we get caliber is the way we determine, you hear it all the time, it's a 22 caliber, it's a 30 caliber. You know, you hear all these, a 45 caliber. It's nothing more than taking the casing and you're measuring the diameter of the bullet. Remember, the bullet's going to be sitting inside. So what we do is, the reason I'm measuring the casing is because if you look at these bullets, a lot of these have been fired. It's difficult sometimes to measure a bullet when it's fragmented. So we'll measure the casing. When we get done measuring that casing, that's how we come up with caliber. It doesn't take into consideration at all how big the casing is. It's just the diameter. That means you could have a 45 caliber in a very tiny casing, or a 45 caliber in a casing 3 times this long. So gunpowder and how fast it moves has nothing to do with caliber. It's about the diameter. Important thing to note here. Certainly in the United States, you know, when we talk about the metric system, a lot of people are saying, well, why do we have millimeter? Why do we have other types of cartridges? The manufacturers get to decide to do that. When we start talking about conversion, because as a scientist, if you have brass on, casings on the crime scene, you're trying to determine what type of gun it shoots out of. When we convert, remember, 1 inch is equal to 25.4 millimeters. So we're converting, we're measuring it, and we're saying, okay, well, for instance, a 50 caliber. When we measure for a 50 caliber, the diameter is 12.94. Okay? So when we start to get the diameter in inches, that's 0.51 inches. So why do we call it a 50 caliber when it's actually 0.51? It should be a 51 caliber. Don't get caught up in that. The manufacturer thought it would be cooler to call it a 50 caliber, when in reality it's a 51. So you'll find a lot of these things. Rarely are they the exact thing. For instance, when we start looking at, there's so many different calibers. We've got 9 millimeter, we've got 10 millimeter, because the manufacturer chose to use the metric system. Now, when you're looking at a 10 millimeter, it's very, very close to a 40 caliber. On duty, I carried a 40 Beretta, 40 caliber, because the manufacturer of Beretta decided to use, inches, so it's a 40 caliber. If you measure a 40 caliber and a 10 millimeter, they're almost identical. 10 mil would be a Glock. If you're on the stand as an expert, you're going to look foolish if you say this was a 10 millimeter when later it found out it was a 40 caliber, when we're talking about, tiny, tiny difference. So understand that's how we come up with calendar. Before we leave, I want to talk about something that's extremely important. This is the components of the actual, when we're talking about casings and bullets that we find in a crime scene. What we see a lot on TV, or maybe you don't, we have bullets that were caused, or the bullets come and hit holes in my crime scene. If I'm trying to determine the caliber and the trajectory of that bullet, it becomes extremely important in court to know who shot that bullet at that person who's dead and why do we have holes in the wall. It tells us a story. So if we come here, for instance, in a crime scene, we got dead bodies in here, we got bullet holes. In a crime scene, every bullet hole, I've kind of mimicked a bullet hole here. Okay, what we typically do when we find bullet holes is we have very, very expensive, I'm going to be using something very cheap today, but what we do is we come up to the bullet hole and we first put something inside. This is called a rod. We have rods and cones. The rod and cone, the cone will determine what the caliber of that hole is. So we'll know this was caused by a .223 AR-15 based on the cone that we put in. Then we put the rod. The reason we put the rod is we want to know where was the person that shot and created this hole standing at the time. A lot of this is going to be based on where the casings are, but this is what we do. We have very expensive lasers. After doing this, we take the laser and we turn it on, and we very carefully now look at the other side of the room, and you'll see that my laser is pointing over there. So at that point, once we get somebody, you'll have to have two people. We're going to have somebody stand here, and we're going to do what we call stringing. Stringing is nothing more than in a crime scene, I want to see the trajectory of that bullet with a string so it can kind of put my story together. So I'll come over here, I'll put a string, I'll follow that string to where my laser was. Here's where my laser was. So we know that on this straight line, remember, back to math, 2 points on a line, straight line. We're going to come over here. We're going to connect that string. We know that this was the path of that bullet. What we don't know is we don't know where the shooter was standing on this path. What are we going to do to find out where the shooter was standing? Well, that's simple. We know based on, once we've identified the gun, we know that it shoots out semi-automatic casings. We're going to be looking for casings. We know on this gun that it's going to shoot casings out. And it's going to shoot casings out if the person was right-handed, probably like this. So if I'm in that crime scene and I'm seeing casings right like that, then I know I'm going to go on this straight line and I'm going to walk to where we suspect, and about right here is where it would shoot the casings. We put an X right here. We put an X right here based on we suspect that the person that shot creating that hole was standing right here when this occurred. We're putting the whole story together. Trajectory is extremely important. It has proven whether police officers have shot people that they should not have shot because their life was not in danger. It tells us an extreme story based on projections. So understand the types of the firearms, the components of the bullets, the casing, and then this idea of this trajectory when we talk about ballistics. I have extremely complicated equipment. If this is something that you're really into, I've got conversion tables telling you all the different calibers. I've got a lot of stuff, folks, that normally I would hand out to you. If this is something you would like, get a hold of me. I'll be glad to let you come in here and do all kinds of fun with ballistics. I've got lasers, I've got tripods, a lot of fun stuff that hopefully when this is all done, you can come back and I'll let you mess with. If you have questions, send me an email.